Hello, my name is Ryan McKee.
And this is Lab 2, Charged Tapes.
In this lab, we created a better coding
Model of the experiment we performed in Lab 1, using line charges instead of point charges. The purpose was to get a more accurate amount of excess charge.
This lab used the physical principles
Of charge attraction and repulsion, as well as electric field and force and gravity. It also used the models of line charges and Coulomb's law. For the purposes of this lab, line charges are rows of point charges that feature a uniform distribution of charges. Coulomb's law is a useful equation that allows us to find the electric force between two charges. Line charge models are shown in the lower picture, and the top picture shows the electric field point charges generate.
In this lab, I found that the
Total excess charge of each piece of tape is 0.321207 times 10 to the negative 9th coulombs. This is much smaller than the estimate I found in Lab 1, which is around 1.3 times 10 to the negative 8 coulombs.
In this lab, I had to
assume air resistance was negligible. This was reasonable because we did not study the movement of the object, so air resistance would have little to no effect on the data. I also had to assume the two tapes had the exact same excess charge. This was reasonable because the same processes were applied to each tape to give it a charge.
In Lab 1, we used
one charged piece of tape to float another charged piece of tape. Measuring the maximum distance the charged tape would still flip up gave us the electric force that equals the gravitational force. We can then set the force of gravity equal to the electric force and solve for the excess charge on each piece of tape. In this experiment, the system was the top tape, the surroundings were the bottom tape, and everything else. And the initial condition was the top tape at rest with minimal influence from electric fields.
In the last lab,
we coded a model finding the excess charges treating the tapes like a point charge. However, this assumption introduced a lot of error. So in this lab, we reworked the model to find the excess charge, assuming the tape was a line charge. This model is more accurate because it is a better reflection of reality.
On the left is the visual model the code created.
The small green arrows are the electric force, and their sum is the white arrow. The yellow arrow is the gravitational force. As you can see, the sum of the electric force equals the gravitational force. The code that I have shown is calculating the net electric field of the line charges. This involved measuring the electric force each point generated on each one of the others, and then adding them together.
This model is a fairly good estimate of
the real world. There are multiple particles in the line charge, and the sum of their interactions creates a similar effect as the real-world scenario. However, this model is not completely accurate. It simplifies the charges to a 2D line instead of a 3D plane, and it doesn't have nearly as many particles as the actual pieces of tape. This introduces error and means the simulated excess charge will be different than the actual excess charge.
There were multiple sources
of error in this lab. It was difficult to measure the maximum distance between the tapes accurately, which could have introduced error. Handling of the tapes could also have introduced error in the system, as charge could have escaped through my hands. As the excess charge decreased, so did the maximum distance the tapes would affect each other. A final source of error was the line charge estimation. This estimation is not perfect, as it does not actually take into account every particle in each piece of tape. This means that the actual amount of excess charge present would have been different than the amount found by the model.
If the tapes were considered a point
charge rather than a line charge, then the model would be much less accurate. This is because the charge tapes look and act more like line charges than they do point charges. The point charge and line charge model have different estimates of excess charge because the point charge does not take into account the many different interactions between particles in the tape, while line charges do a better job modeling that. This means line charges are a more accurate model because they are a better representation of what's actually happening. Thank you.